This next example we're going to look at is number 16 from the lecture examples. And it is a problem. So it says, what is the empirical formula? So it's an empirical formula question. So what would the empirical formula of a compound be if it is composed of 73.63% carbon, 12.36% hydrogen, and 14.01% oxygen? And so the rules for solving an empirical formula question are: step one, you assume that you have 100 grams. And so if you assume that you have 100 grams, each of your percentages then ends up being the grams of each substance. And so when you think about it, what a formula expresses is the ratio of each atom to the other. So the only way for us to compare ratios of atoms is in terms of moles. So step one, you assume that you have 100 grams. Then your percentages become a gram value. We need to put that in terms of moles, and then we can compare the number of moles to one another, and the simplest whole number ratio of the moles is the empirical formula. So that's going to give us, so if we assume the 100 grams, then we're dealing with 73.63 grams of carbon, 12.36 grams of hydrogen, and 14.01 grams of oxygen. I'm going to take each of those gram numbers and then convert that to moles for each of the elements. And so that puts us at, so we're going to take 73.63 grams times, it's 1 mole of carbon for every 12.01 grams. For hydrogen, it is 1 mole for every 1.008 grams of hydrogen. And for oxygen, it is 1 mole of oxygen for every 16.00 grams of oxygen. And so that means that we have in our assumed 100 gram sample, let's see, need more hands. All right, that pretty much works. It's going to be about 6 moles of carbon, 73.63 divided by 12.01, you get 6.13 moles of carbon. You get, I mean, that's just going to be a smidge less than 12, right? 12.26 moles of hydrogen, and then you get less than a mole, 0.8756 moles of oxygen. So it's still on them? All right, just barely. All right, so now we have the moles, and you need to find the simplest whole number ratio of moles. Now, how am I going to find the simplest whole number ratio of 0.875 to 12 to 6.13? And so the easiest way to do that is you divide each of these by the smallest value of moles. Because if I divide 0.8756 by 0.8756, that's going to equal 1. And that means I have the 1 mole of oxygen, and that's the simplest whole number you can have. And so if I get that for oxygen, and then that's going to put everything else in terms of the oxygen. So that's how we're going to start to get that simplest whole number ratio value. So I'm going to kind of work backwards here on the board. All right. So if we divide each of these by the smallest one, so then we're going to take 0.8756, and so that equals 1 mole of oxygen. We're going to divide 12.26 by 0.8756. So 12.26 divided by 0.8756. And we get 14 moles of hydrogen. And then we're going to divide the 6.13 again by the 0.8756. And that's going to equal, I think it's 7 is what that comes out to be. 6.13 divided by, and sure enough, it's 7 moles of carbon. And so then that's our formula. It's 7 parts carbon for every 14 parts hydrogen for every 1 part oxygen. So we would express the formula as C7H14O. And that would be the empirical formula for the compound.